Right, after we talking about in the example how to find the area cumulative from the left. Remember, in that example, we find the area cumulative from the left, but this time we were talking about the area to the right. Suppose we have a person has a result above -1. Above -1. So we want to know the probability. So we were interested in the probability. This time we have the score is above -1. How can we find the probability? So basically we still know the 0 is our mean, always in the middle, right? This time the score is -1. So it should be on the left side. So we label -1 about this position. But this time we know which direction we should go. We're talking about above -1. If we are saying above, which means we actually goes to the right side. Agree? If it's below, we goes to the left. If it's above, goes to the right. We go to the right. So we shaded the right part. First, find the -1. We set a bar. Then we work on which side we are interested in. This time we are interested in the right side. So we shaded the right side. Next step, we still need to check the table. Of course, this C is -1. We check the negative C table. So we check -1. 1, 0, right? So from the bottom to the top, we have a -0.0 to -3.5. So we can find which one is -1.0. Because the last digit is 0.00. So we check the top row, we can find it's just the first column. So we can easily find that the corresponding value is 0.1587. This value is directly from your table if you check this Z, -1.0. Again, first check -1.0, then check the top row to find which column is for the 0.00. Then you can locate this value, 0.1587. So after that, we should ask ourselves a question. Is that area is the part we are interested in? Check the curve, check the graph here. We actually interested in the area to the right, but this time the area we get it directly from the table is the area to the left. Remember, C table always give you the area cumulative to the left. So how should we get the area to the right? Don't forget that important property of a density curve. The total area under the curve is always 1. So we can use 1 total area, 1 minus the area cumulative to the left to get the area to the right. So 1 minus 0.1587, we get this one. And this one is the area of this shaded part, is the probability we are interested in. Don't forget, when we talk about right, area to the right, we cannot directly use the area directly from the table. We should do something. We should use total area minus the area to the left to get the area to the right. So this is, the remaining part is just the same. We can interpret it. The probability is so 0.8413, so we could say 84% of people have the levels above -1. Next one, we will talk about the area between two values. So between two values. This time we have this, the probability between -1 and the -2.5. We check here. So -1, remember 0 is always in the middle. 0 is always in the middle. So it's -1 and this one is -2.5. We are interested, you check this part, we are interested in this shaded area from -2.5 to -1. So how can we do this kind of problem? We only need to use the first C value. So first, if we use -1 as our first value, we will get this corresponding area to the left. How can we get to this? 0.1587. We use C table. C table is your A2 table, okay? C table. Still do the same thing. Check -1.0 first. -1.0 on the left column and check the top row for the last digit. So you can locate 0.1587 is the area for this value. We do the same thing. Check -2.5 first on your left column. Then check the top row, 0.00. You can locate another area. After that, you always need to find the difference between two area. Again, area. I know lots of students will make this mistake. They first get the difference between two z-scores. Then use that one to check the table to find the corresponding area. This is totally wrong. We first use z-score to find the two area. Last step, find the difference between two areas. And the difference between these two areas is 0.1525. And this is just the probability we are interested in. So here, 0.1525 is the area we are interested in. Is just the probability we are interested in. And this is how we interpret it. About 15% of the people have the score between -1 and -2.5. So this is the generalized rule if we talking about the area between two values. So first, which z-score on the right? We can start with the z-score on the right side. If we have a positive score, negative score, of course the positive score is on the right, right? If we have two z-scores, we start with which one is larger. So for the previous example, we have two negative z-scores, -1 and a -2.5. So we start with -1 because this one is larger. So which means the larger value is always on the right side. Oh, not on the right side of 0. It means right to the smaller value. So here we start with the larger value. We call it a z right. Find the area. Find the area of this one. So we will say C right side. You will find the area 1. So you will have another smaller z-score. You will find the area 2. After that, area 1 minus area 2, you will get the answer. You will get the answer. So these are some notations. This means C between two values, right? C between two values. So this one is C greater than a value. This is the probability. C is smaller than some value. So here the probability is just the area. It's just the area. So next topic we are talking about, if we already know the area, how can we find the corresponding C-score? How can we find the corresponding C-score? First, we will draw a bell-shaped curve. We will draw a bell-shaped curve. Next step, we should identify the region under the curve. We should shade it the part. If it's not a region from left, we should work on the known region that is cumulative from left. What does that mean? So if first step we know we focus on the area cumulative to this side, right side, which means this is not the region from left. So we cannot directly work on this part. We should work on this part. How can we get the area of the left side? If we know the area to the right, we should use 1 minus the right side area to get the left side, right? To get the left side area. Then we can just use this one, this left side area, to check the table to find the corresponding C-score. So basically, we need to find the area cumulative to the left, then use that left side area to find the corresponding C-score. So we can use the C-table or use the technology to help us. So let's check another important definition called the critical value. Critical value is a Z-score. So make sure you understand critical value is a Z-score. This Z-score is a special one. It's on the borderline, separate. So Z-scores are significantly low or significantly high. So basically, you should remember, critical value is just a Z-score, and this Z-score is a borderline. So we have this C sub alpha, which means the area cumulative to the right. So I will show you this picture. What does that mean? So first, C-score. Critical value is a C-score, but this one is a special C-score, right? So Z-score at the borderline. So I draw a borderline here to separate the total curve into two parts, and we focus on this area to the right. This is just alpha. The area cumulative to the right side area is just equal to alpha. So this is called critical value. This Z called the critical value. So let's see, how can we find the Z? How can we find the Z? Because we have c sub 0.025, which means alpha is 0.025 in this case. So how can we find the corresponding c if we already know the area? So first we know this tells you what is the area on right. So if it's just a small part, so definitely it's just about this position, right? C 0.025, 0.025, which means this area is 0.025. Remember, when we want to find the z-score and the area we have is not cumulative to the left, what should we do first? We should find what is the area cumulative to the left, right? Since this 0.025 is the area on the right, so we should find the area of this part. The blank part is 1 minus 0.025. We will get this part is 0.975. This area to the left side is 0.975. Because we cannot directly use this one to check our C table. Because this one is not the area to the left. Your C table only gives you the area to the left. So we use this one to check your C table. And this time, because we have the area, so make sure you check your body of the C. The body of your Z. Obviously, this Z is Z sub 0.025 is on the right. On the right, right? On the right, because the 0 always in the middle. So on the right side. So we should check the positive Z score, the positive Z table. And you should find which value is closest to 0.975. Again, you check the body. Do not check the margins. Margins are z-score. 0.975 is the area. The bodies are area. So we find which one is closest to 0.975. We realize we have find a value exactly equal to 0.9750. So we find the exactly same value here. Then we check the left side, left column. We find it's 1.9, and we check the top row. We find it's 0.06, which means put them together, we get 1.96. Check the Z table body to find the closest value. Sometimes we can, I would say most of the time, we cannot find the exactly same value. We always pick which one is the closest value to this one. This time we find the exactly one, and we know we check the table. We get 1.9 on the left column and 0.06 on the top row. Put them together, 1.96 is the critical value. So here, it's just tell you how can we get the critical value. Basically, this alpha 0.025 means the area on the right tail is 0.025. So first step, we should find the area to the left. Use total area minus the 0.025. So that is 1 minus 0.025. We get 0.975. Then use that value to check the body of your C table. Body. To find which one is the closest one. Then you can locate what is your Z-score. That Z-score is just the critical value we need. So basically, you need to use 1 minus alpha. So if it's C sub 0.1, you need to use the area 0.9 to find the corresponding Z. So that's all for this week. So make sure you check the content if you do not have your own C tables. I will post the C tables for you. Make sure you check the content.